My name is Ross Clark, and I'll be talking today a little about some of the work that my group, the Central Coast Wetlands Group at the Moss Landing Marine Labs, did in partnership with the Nature Conservancy, Revel Coastal, ESA, and funded by the Ocean Protection Council. Some work we did to evaluate future vulnerabilities along the coastline of the Monterey Bay as a result of changes in wave patterns and rising seas. The intent of the project was to evaluate what these future risks and hazards are and help some of our local municipalities, public works directors, etc., understand the risks and start to identify short and medium term actions they can take to increase the resiliency of our coastline to these hazards, as well as inform the community about some of the alternate strategies we could take and some of the secondary benefits or consequences that we may see along our coastline if we adopt those various policies and programs. First and foremost, I wanted to talk a little bit about future climate change projections and how we use those projections to do our analysis. California has adopted a set of sea level rise rates projected through the year 2100, and on the slide you can see three curves, red, orange, and yellow. Each of those is a future sea level rise rate curve dependent on the amount of greenhouse gas emissions we add to the atmosphere over the next 90 years. Specifically, if we are active in reducing greenhouse gas emissions globally as well as locally, we would hope to see an environmental result which would minimize future ice shelf melting and expansion of our oceans, and see a fairly limited increase in sea level rise as projected by the yellow line. The orange and the red are projections of the rate of sea level rise into the future under higher greenhouse gas emissions. The red line was seen as a continuation of emissions over the last decade or two into the future, which would result in over 159 centimeters of sea level rise by the year 2100, or about 5 feet. First, we line of defense for resiliency to sea level rise, of course, is to minimize the rate of sea level rise into the future. And so aggressive actions to reduce greenhouse gases, of course, are paramount importance. And fortunately, most of the communities in the Monterey Bay have climate action plans and have identified mechanisms to reduce community as well as municipal emissions, and are actively implementing those plans. There's also a lot of state funding to support those efforts, and a lot of great programs like Monterey Bay Community Power that are working regionally to reduce the carbon content of our electricity load as well as other sources of emissions. With that, we adopted three time horizons, 2030, 2060, and 2100, and adopted future sea level rise projections for those time horizons, and then looked at the cumulative and independent hazards associated with various risks of climate change and sea level rise. Specifically, we've looked at future dune and cliff erosion rates under these different sea level rise scenarios. We also looked at the potential for coastal flooding, where winter storms with higher intensity winds and waves, which is one of the results of climate change, compounded by higher sea levels, would cause inland flooding, wave overtopping and inland flooding in the future. We also look specifically at rising tides, the projections of that increase in high water elevation along our coastline as predicted in this slide. And then we also looked in 2 of our communities at the compound hazards of higher oceans with increased rain events causing a greater river discharge, which would flow downhill and meet higher ocean levels near some of our coastal communities. And we looked at the future hazards of that scenario for the city of Capitola and the community of Moss Landing, both of which have rivers that discharge through those communities. Historically, as far back as 2009, we've had regional and state models that have been used to depict future hazard areas along our coastline. And here's an example of one of those maps that was generated previously. All of these maps, I'd like to point out, are currently available at the Nature Conservancy website, coastalresilience.org. When we first started seeing and discussing the implications of these hazard areas on these maps, I quickly realized that these maps were great at providing a sense of urgency, but they, which is why I call them, I call them the maps of doom, but they were not useful to decision makers, public works officials, property owners, at informing them what action they would need to take to minimize or mitigate these future hazards. And so that's what a lot of the focus of our work over the last few years has been focused on, is really providing those decision makers with more specific information on what these projections mean for their local communities. And to do that, we had to disaggregate the combined risks into their individual hazards, as I discussed on the previous slide, including cliff erosion, wave and coastal flooding, tides, and river flooding. With these maps, the first thing that many of us did was start to overlay them over current land use and look at future infrastructure that's vulnerable. And you can see on the right that a compilation of total buildings vulnerable within these zones into the future. If we go to the next slide, we were then able to also identify what infrastructure specifically were in those zones and tabulated it under various land use and building categories, including residential, commercial, and public buildings. We're also looking at schools, libraries, emergency services. We're also able to identify acres of farmland, hazard sites, as well as infrastructure, as roads, bridges, highways, sewer and water pipes, etc. We're able to quantify the number or amount of those various land uses and infrastructure that are vulnerable within these zones and predict those numbers out into the future. So we get a sense of the relative scale of coastal infrastructure that is at risk as we move into the future. Hopefully providing information both to the public and to our cities and counties on the relative scale of these hazards moving into the future. We hope that by providing this information, it allows the community, both residents, businesses, and city officials to have more information and hopefully use that information to make more strategic long-term decisions on how we invest limited resources to adapt or become more resilient to these future hazards. As I discussed before, there are a number of different hazards enveloped in those those overarching hazard layers, and we work to disassociate those individual risks. And here's a picture of representing each of those, both cliff erosion and dune erosion, which are primarily caused by increased wave impact associated with higher seas and stronger storm events, crashing against the back of the beach more frequently, causing increases in the rate of erosion. Rising tides, of course, are cause as the ocean levels rise, and those king tides or monthly high tides become higher, flooding some of our coastal infrastructure that was designed to be just above historic tidal range, now is within that range. And we'll see more and more frequent flooding as sea levels rise. And then the periodic impacts we've also evaluated of storm flood impacts, large storm events, higher coastal seas associated with the storm fronts, compounded by higher ocean levels, leading to coastal areas being impacted both by waves and flooding more severely and more frequently. We did note that some of these impacts, specifically river flooding and coastal storm flooding, are temporary impacts that our communities have seen in the past and responded to and rebuilt after. And that will continue in the future, although the relative frequency of those impacts may become more and more frequent, making it more costly and less feasible to rebuild afterwards. But it's important to note that some of the predictions are temporary, whereas others, including tidal inundation or monthly flooding and cliff erosion, which is the actual loss of the parcel onto the beach, are likely permanent hazards that once seen, it's very difficult to rebuild in a way that is cost effective and allows a similar use of the property. So as part of our reports, and there are several of these reports. There's the City of Capitola report. There's the Santa Cruz County Climate Vulnerability and Adaptation report, as well as the Monterey County Moss Landing Community Vulnerability report, are all online at centralcoastwetlands.org. And then we also did some work with the City of Santa Cruz, and their hazard report and adaptation plan are available on the City of Santa Cruz website. Here are a couple of examples of maps depicting hazard zones for individual risks once we disassociated the individual predictive hazards within the overall maps into their individual hazards. We can show incremental risks to property and land use individually. So on the left you can see coastal erosion for the Moss Landing area, both at the Monterey Dunes Colony and near the Moss Landing Harbor. And we've identified properties and infrastructure that is vulnerable to these erosive forces for each of the time horizons, red being 2030, orange being 2060, and yellow being 2100. Similarly, the hazard zones are color-coded, as shown on the slide. And one of the important things for coastal erosion is that in many places, including Moss Landing and the Dunes Colony, there are protective structures, coastal armoring, riprap, rock revetments, concrete walls, currently in place that protect some of these structures from wave impacts and flooding. And for our analysis, we accounted for that infrastructure that's currently in place and eliminated properties that were behind those structures as being part of the hazard zone for the 2030 time horizon. we did this to reflect that we have current protective infrastructure in place that is likely to continue to provide that service through the year 2030. We did talk with a lot of engineers and some of our other science panel representatives, and did agree that by 2060, many, if not most, of the current infrastructure that's in place along the coastline providing this protective role will be either undersized or have reached the end of its functional life by the year 2060. And so for the 2060 and 2100 analyses, we did not include the protective functions of those that infrastructure within the hazard zones. So we eliminated any protection that infrastructure provided for those time horizons, and showed that those properties would once again be at risk. Now, many will say, well, that doesn't seem appropriate, because of course we would rebuild those structures once they see the end of their life, and in many cases that's probably true, but that would be a response or policy decision in the future, and we wanted to account for that as a future response option, not a foregone conclusion, because there would need to be different designs, and of course incremental costs of doing those future construction projects. And so those costs were in the future, so we also wanted to relay it to future risks. But the layers behind it can be modified to make the assumption that future infrastructure is replaced. It just needs to be accounted for in the cost component of the our overall analysis of alternate response strategies, as well as the benefits of protecting the structures. Of course, some of these structures will be overwhelmed by the future predicted hazards. Waves will surely overtop some of the structures that are currently in place and not provide that protection. And local engineering designs will need to be evaluated to see what level of construction would need to be done to provide the same level of protection as we see now. And in some cases, landowners or the community may determine that infrastructure is either too costly or too extensive, blocking views, limiting coastal access, gobbling up much of the beach, all of which may be considerations that would make us rethink adopting those protective actions in those locations. Much of that is what we're hoping that this report and some of the other work that's being done will help inform decision makers before they replace infrastructure in place, but to really think the long-term results of current and future actions and what all of that will add up to and what our coastline will look like in 2100, which is really the ultimate objective of our work, is to inform people so that we can all make decisions to transform the coastline as we respond to climate change and sea level rise in ways that maintain the beauty of the Monterey Bay. With that said, we'll go through some of the more of the slides. On the right, you can see Moss Landing, vulnerability to rising tides, and you can see the darker areas are pretty much within the current wetland and harbor areas, but as you get into the 2060 and 2100 predictions, tides start to inundate some of our built community of the Moss Landing area, flooding the Marine Lab where I work, as well as much of the Moss Landing community, harbor infrastructure, pump stations, etc. To note that there are two structures, tide gates, at the Potrero Road at the bottom of the map, and the Moss Landing Road, which is right kind of in the right center, that protect the lower portions of the inland Morocco Slough and Old Salinas River from full tidal action, and that those structures we've assumed will continue to provide a level of protection through 2030, but for various reasons we'll talk a little bit about in the future, are likely not to be able to provide the same level of flood relief by 2060 and 2100, primarily because they were not designed to provide flood protection under circumstances where the ocean level in the harbor is 2 to 5 feet higher, and water flowing down the watersheds and meeting the tides in the harbor. Those flows are increased significantly as climate change leads to more intense, less frequent rain events. So you can see how the combination of the different hazards leads to different vulnerabilities. But by disassociating and identifying these risks individually, we hope we can help identify adaptation strategies that are most effective, as well as being most respectful and cognizant of our natural beauty of the coastline. So one of the takeaways of looking at those individual hazards for infrastructure throughout the Monterey Bay was that we realized that different areas of the coast and different infrastructure are threatened by different hazards at different times. Here's an example from Moss Landing, where coastal flooding is clearly the #1 threat for 2030. Rising tides posing very little risk to buildings currently, but as well as erosion. River flooding, which we've known from recent storms, does risk a number of buildings now, and all of these hazards increase into the future, with coastal storm damage being the leading to the most number of buildings, many of which are in the Monterey Dunes colony by 2100. Rising tides does begin to pose a greater hazard as we get close to 2100, leaving at least 100 individual buildings at risk of monthly flooding, and most of those buildings cannot accommodate that level of periodic flooding. Here's another example for the Pajaro Valley of the risks of rising tides. Sea level rise is slow, and that risk will, as you saw in the curves, become more and more significant as the rate continues to rise through the next 80-90 years. But some of our low-lying river valleys are quite close to sea levels currently, and so even small increases in ocean levels can lead to significant flooding of these low-lying valleys into the future. The Pajaro Valley here is an example where you can see by 2030 portions of developed and agricultural areas will be vulnerable to monthly flooding. Some of this area currently has tie gates and other structures in place, much of which is undersized for current risks, let alone increased hazards as predicted in the future. Some of these areas to the north east of the map are currently wetlands that have been restored and are maintained by the city and the county. They may see increased water levels, which could cause changes in vegetation. It could also possibly lead to more salt water flowing back into these brackish and freshwater systems and causing a change in habitat type. But as you can see on the right, in these low-lying areas, quite often we've recognized the flood hazard and haven't built a lot of buildings, both commercial, residential, or public. But there is a lot of farmland, as well as roads and underground pipes in these areas that are vulnerable to these predicted risks, and which will cause impacts to our food supply, as well as impacts as to access to some of these areas, important for emergency response, as well as a reduction or failure of some of our utilities to some parts of our built community that are not within these hazard zones, but the infrastructure that supports them is. Storm flooding caused by higher seas and more intense waves does lead to coastal impacts along the entire coastline, much of which in many places is already protected by coastal armoring. In these two maps you can see the black and white hashed line. Those are indications of where we currently have coastal armoring along the coast. But we've seen that while that armoring helps with current wave impacts, at least most of the time, in the future as those waves become higher and more intense, much of that infrastructure will be undersized, leading to wave overtopping and inland flooding of a lot of these low-lying built environments, including some of our low-lying areas like Capitola and here Rio del Mar, that are some of our visitor-serving beach community areas that are closest to sea level and have been identified to be extremely vulnerable to wave-induced flooding.